Welcome to Tech Math Tutorials. Today I want to talk about rational and irrational numbers. So we are going to start with the definition. We are going to define a rational number first. A rational number is a real number that can be expressed in the form a over b, where both the a and b are integers. This means a and b are elements of this set of integers. And b must be strictly not be equal to 0. Because if b is equal to 0, if you look at this one, b is in the denominator. If the denominator is 0, we know very well that every fraction that has a denominator 0 is undefined. So we want to avoid such a situation. For example, 4 is a rational number because we can express 4 as 4 over 1, where both 4 and 1 are integers. So we can just say in short, any integer is a rational number because we can express any integer as itself over 1. So any integer is a rational number. Example number 2, 0.2. 0.2 is a rational number because we can express 0.2 is 1 over 5, where both 1 and 5 are integers. Likewise, we have the square root of 64. The square root of 64 is a rational number because we can simplify this to 8. We can simplify this to 8. So we are saying as long as we can simplify any number in any form and end up having something in the form a over b, where both the a and b are integers and b is not equal to 0, then that number is a rational number. Another example is the cube root of minus 8. The cube root of minus 8 simplifies to minus 2. This simplifies to minus 2. So we are saying minus 2 is an integer. As I said before, any integer is a rational number because we can express minus 2 as minus 2 over 1. Right, moving on to minus 4 over 7, Minus 4 is a rational number. Minus 4 is an integer. 7 is an integer. So minus 4 over 7 is a rational number. Moving on to this one, we can express this one as an improper fraction. Right, 5 by 3 is 15 plus 2, 17. So it's 17 over 5. So we are saying this is a rational number because 17 is an integer, 5 is an integer as well. So this fraction, this mixed number, is a rational number. Right, moving on to the last one here, log 27 base 9. We can simplify this one and find the final answer, 3 over 2. And 3 is an integer, 2 is an integer. So this one is also a rational number. On the other side, we have an irrational number as a real number that cannot be expressed in the form a over b, where both a and b are integers and b is strictly not equal to 0. For example, we have the square root of 3. The square root of 3, we can't express the square root of 3 in the form a over b, where both a and b are integers. Pi. I want to explain something here. When we are saying pi, we are talking of something that is other than 22 over 7. Some may ask, why are we saying pi is not a rational number? Pi is not equal to 22 over 7. 22 over 7 is just an approximation to pi. Pi has its exact value. You can find that exact value on the calculator. Pi is an irrational number. 22 over 7 is not equal to pi. This is an approximation to pi. Okay, clear on that. Then the cube root of 5. The cube root of 5 cannot be expressed in this form where both a and b are integers. Right, this one, I like this one. In this case, we have this one. and this one. We have the square root of 7. The square root of 7 is not an integer. Of course, this fraction is in the form a over b, but in this case, this one is not an integer, so it is not a rational number. Hence, it is an irrational number. We are saying we will take this one as a rational number if and only if this one is an integer and this one is also an integer. Right? Moving on to log 3, we can't simplify log 3 and express it in this form, a over b, where both a and b are integers. Right, here is your exercise. I want you to try this one. From the list of numbers below, separate the irrational numbers from rational numbers. So I will give you a few seconds. I want you to pause this video, work out this problem, separate irrational numbers from rational numbers. Then after that, I'll give you the answers. Right, here are the answers. Right, under irrational numbers, we have log 100. Log 100 simplifies to 2. So we are saying log 100 is a rational number because 2 is an integer, hence it is a rational number. All integers are rational numbers. Right? Number 2, the square root of 2 and a quarter. We can simplify this. If we express this one as an improper fraction, 4 by 2 is 8 plus 1, 9. 9 over 4. The square root of 9 over 4 is 3 over 2. And 3 over 2 is a rational number because 3 and 2 are both integers. We have 22 over 7. 22 is an integer. 7 is also an integer. Hence, 20 over 7 is a rational number. We can also simplify this. This simplifies to minus 6. This simplifies to minus 6. So minus 6 is an integer, hence it is a rational number. The square root of 169, the square root of 169 is 13. So it is a rational number because it is an integer. We can express this as 13 over 1, where both the 13 and 1 are integers. On the other side, irrational numbers. Under irrational numbers, we have the square root of 6. Square root of 6 cannot be expressed in the form a over b, where both a and b are integers. Minus pi is an irrational number as well. Thank you very much for watching. Please do not forget to subscribe, like, and share our videos. Also like our Facebook page.